Dear viewers, in the last few weeks and months, some volcanoes have erupted on Earth, some of which have very different eruption behavior. The Fagradalsfjall volcano erupted on March 1921 and has been active since then. The Soufriere volcano on St.Vincent erupted on April 9, 21. Finally, on May 22, 21, the Niyiragongo erupted in the Democratic Republic of Congo, formerly Zaire. Furthermore, the Pacaya volcano in Guatemala was often in the news and has been more or less constantly active since 1965. These outbreaks were very different. While the eruption in Iceland has so far presented itself as a tourist attraction, the Congolese volcano spreads panic. The outbreak of St. Vincent was also catastrophic, albeit for different reasons. The reasons for the differences in eruption behavior are to a large extent to be found in the composition of the magma and the lava. There are many chemical elements on Earth. It is interesting, however, that 4 elements already make up more than 90% of the Earth's mass. In detail, these are oxygen with 32.4%, iron with 28.8%, silicon with 17.1%, magnesium with 15.8%. Together that is 94.1% of the Earth's mass. With 1.7%, nickel is far behind in 5th place. Iron is by far the heaviest element of the 4 front runners. After the Earth had formed and slowly came to rest, the elements sorted themselves according to their density. Iron with 74 kg per cubic meter, silicon 2336, magnesium 1738, oxygen 1429. The iron slowly slipped towards the interior of the Earth, while the other elements were more likely to be found on the surface. Oxygen is gaseous and an important part of the atmosphere, but it is also very reactive and therefore also occurs as an important component in rocks. A large part of the sand deposits on Earth consists, for example, of quartz. A silicon dioxide. Quartz is the second most common component of rocks after feldspars. Feldspars, the chemical formula is written here, are the most common rock-forming minerals. Silicon and oxygen are also prominent here. Quartz and feldspars together make up about 90% of the rocks. So at some point on Earth we had the following situation, which is in principle still valid. The top solid layer is the Earth's crust, which largely consists of light elements, and underneath there is a large area in which the iron content is increasing with depth. This is the so-called mantle of the Earth. This mantle consists of solid rock, which, however, behaves malleable in geological time periods. There are convective currents here, which are caused by different temperatures. As I said, these currents are all very, very slow. In certain areas, however, the mantle also consists of molten rocks, the so-called magma. The formation of the magma is not yet fully understood. Since the liquid magma is lighter than the almost solid Earth's mantle, it rises and collects in magma chambers. The different composition of the magmas has a decisive influence on the type of volcanic eruptions. If the magma consists of high proportion of magnesium and iron, it is called Mafic, where Ma stands for magnesium and F stands for ferrum or iron. If the magma has a high proportion of lighter elements, it is called felsic, where Fel stands for feldspar and Si stands for silicon. There are smooth transitions between the two types of magma. In the past, people also used the terms basic and acidic magma because silicon dioxide was also known as silicic acid. However, this has nothing to do with chemical acids and bases, which is why these terms are no longer used. At this point, I would like to briefly explain the difference between magma and lava. In principle, there is no difference other than liquid rock is called lava when it flows above ground and magma when it is below the surface of the earth. There are essentially three types of volcanoes. One type is a so-called hotspot volcano. Hotspots are areas of magma that remain constant in the upper mantle over long geological periods. This magma rises to the surface at regular or irregular intervals and then leads to an eruption of a volcano. The best known example of a hotspot is certainly Hawaii. The other two types of volcanoes are caused by continental drift. The above-mentioned convection currents in the Earth's mantle ensure that the lighter crustal plates slowly float with these currents. The first scientist known to have the idea of continental drift was a meteorologist and climatologist Alfred Wegener. When looking at maps, we also notice the similarity between the west coast of Africa and the east coast of South America. Alfred Wegener was for sure not the first to notice these similarities, but in 1911 he became aware of the paleontological connections between South America and Africa and developed his idea. In the middle of the ocean lies the mid-Atlantic ridge, which has exactly the same shape. He didn't know this back then, however, but the theory had later been proven by this ridge. The lava emerging on this ridge was Ferrous, and the iron particles were aligned with the Earth's magnetic field when they solidified. The orientation of these particles changed by 180 degrees at regular distances from the ridge. This did prove not only the continental drift, but also the polarity reversal of the Earth's magnetic field, which occurs over long periods of time. This brings us back to lava and volcanism. The earth plates move away from each other because between them there is an ascending convection cell in the Earth's mantle. When the tectonic plates move away from each other, the crust in the middle between the two cracks again and again, and through these cracks, lava with a high proportion of iron and magnesium rises to the surface. It flows away from the mid-Atlantic ridge, solidifies, and a new part of ocean floor is created. This is the second type of volcanism after the hotspot. If tectonic plates move away from each other via ascending convection currents, they must collide via descending convection currents in other parts too, and that's exactly what happens in the other great ocean, the Pacific. America pushes its way across the Pacific crust from the east. This subducts under the American plates into the Earth's mantle. A mountain range, Andes Rocky Mountains, folds up, similar to when you push a kitchen towel together on the dining table. In the west of the Pacific, too, the Pacific plate slides under its neighbor, here the Eurasian plate. Volcanic archipelagos such as Japan and the Philippines form because of that subduction. But it is not just the crust that is submerged in these areas. Because the crust is saturated with ocean water, this water penetrates into these depths, and at some point the water will evaporate, and so the density of the whole sinking mass changes. It becomes lighter and rises again as magma in some places. At some point this magma reaches the surface again and a volcano is created. The magma that pushes to the surface here has a significantly higher silicon content than the magma on the mid-Atlantic ridge, because this magma is made of crust materials. Which brings us to the differences between iron-containing Mafic magma and silicon-containing felsic magma. Ferrous magma is thinner than magma containing silicon. And now let's look at the outbreaks of the past few weeks, and with our knowledge now we can compare and understand the differences. As already mentioned, the eruption of the Icelandic Fagradalsfjall presents itself as a tourist attraction. Iceland is situated on the mid-Atlantic range. The Ferrous lava flows from the cracks in the crust like blood from a finger if you cut yourself with a knife. The lava flows quietly, sometimes it splashes like a fountain, but you can get quite close to the volcano without anything happening. However, you should watch out for harmful gases and always approach with the wind in your back. The magma and lava of the Congolese volcano Niyiragongo both also have a high iron content, because even under this volcano there is an ascending convection current in the Earth's mantle. The crust drives apart, rips open, and the magma finds a way to the surface. An ocean will form here in the distant future. The fact that this outbreak creates panic and is not a tourist attraction is due to the orography. While the area in southwest Iceland is rather flat, the volcanoes of the Congo arise above 3,000 meters height. There is a lava lake in the volcano's crater. When this lake leaks, the thin lava rushes down to the valley at a speed of 50 to 100 kilometers per hour. The city of Goma is less than 50 kilometers away, so you may have less than an hour perhaps to get to safety after an outbreak. So the panic is justified. Completely different conditions prevail when the magma and lava of a volcano contain a lot of silicon. The lava flow at the Guatemalan volcano Pacaya slowly creeps down the mountain. It approaches people's fields and houses very slowly. There is enough time to clear everything and disappear, but usually you can't stop such a lava flow. A major problem with silicon-containing magma is that it can solidify when it rises, thus blocking the path for the following magma. This accumulates below the stopper. At some point, the pressure from below becomes too big, which, like an open champagne bottle, blows the contents of the magma chamber and the entire stopper to great heights. This happened at the Soufriere on St.Vincent. This column then quickly collapses, and the mixture of lava and hot ash rushes down to the valley at high speed. This is called a pyroclastic flow, and the entire eruption is called a plinian eruption. Melting ice and snow masses on high volcanoes can also have devastating effects. Another complication can arise when rain tears down the freshly fallen volcanic ash. This phenomenon is called a lahar. Another type of eruption happens when rising magma comes into contact with groundwater and the water suddenly evaporates. This explosion often creates a maar. A major danger with submarine volcanoes or volcanoes on islands are tsunamis that may occur. There are also volcanoes that have produced different levels of lava throughout their history. It may be that there are areas in the Earth's crust where ferrous and low iron magma are close together, and depending on which reservoir is being tapped, this volcano's eruptions can be either calm or explosive. The 4 eruptions that went through the news this year exemplify the full range of volcanic eruptions that exist. Let's enjoy the peaceful outbursts, like in Iceland, and let's hope that everyone can get to safety quickly from all other eruptions and their consequences. Thank you for your attention. I hope we will see each other again in one of my next videos. Bye bye. This is Norbert from the channel Opa Spielt Grandpa Plays. I wish you a nice day, and we will see us in sooner or later. Bye bye.